Section 8.4, Plane Curves and Parametric Equations. If f and g are functions defined on an interval I, then the set of points f of t comma g of t is a plane curve. The equations x equals f of t and y equal g of t, where t is in the interval I, are parametric equations for the curve with parameter t. Note that the parametric equations are graphed on Cartesian coordinates. So we find a table of values for a range of t values and sketch the curve using the points. Now by replacing t with negative t, we get a different set of parametric equations. Following the same process, we can graph these equations. Let's replace t with 2t. We get a different set of equations, and note that all three equations have the same graph with different values of t. If we solve the y equal t minus 1 for t and substitute it for x equal t squared minus 3t and simplify it, we get x equals y squared minus y minus 2. Let's find parametric equations for a line passing through 2, 6 with a slope of 3. So for every t value of increment 1, x increases by 1 and y increases by 3. This is because rise over run is 3 over 1. Thus, x equals 2 plus t and y equals 6 plus 3t. For increment of 1, for t values 0, 1, and 2, we get the 3 points on the plane. And so the line is defined by these parametric equations. If we use an increment of 0.5, we have 3 other points forming the same line. A cycloid is a curve traced out by a fixed point P on the circumference of a circle as it rolls along a straight line. Let's focus on a specific moment of the cycloid to find a formula for its coordinates. The arc length is a times theta, since radius is a. Sine of theta equals distance of the line segment PQ over A, which gives us the distance of PQ as A sine of theta. The x-coordinate of point P is the arc length minus the distance of the segment PQ. So x equals A times theta minus sine of theta. We also know that cosine of theta equals distance of the segment CQ over A, hence distance of the segment CQ is A cosine of theta, and y-coordinate is the radius minus the distance of the segment CQ. So y equal A times 1 minus cosine of theta. So given x equals r cosine theta and y equals r sine theta, we can find a function f of theta where r equals f of theta. That is, x equals f of theta cosine theta and y equals f of theta sine theta. Now replacing theta with t, we get parametric equations x equals f of t cosine of t and y equals f of t sine of t. These are suggested homework problems and required ALEKS homework for section 8.4.